No, it's all right, Jenkins. Still got the lurgy, but it's all right. I got a note from Mrs. Tweed to get me off of filming. Yeah, give it to the director. Yeah, stop Nelly podging about, buy milk, eggs, and dog food. Oh, best get on then. What's that, Jenkins? Big hat? No, my head shrunk. Hello, welcome to Tweed's Garage. In this video, we were going to do some more on the Scott, but I got distracted. Yes, said in my school report, easily distracted. Yes, looking at squirrels and stuff like that out the window. Oh, squirrel. Yes, so yeah, I was going to get on with the Scott, but I happen to be standing next to my Clarkson cutter grinder, and having seen somebody else work on theirs and fiddling with a handle and that, thinking I really must do something about that, I decided to do something about that. So yeah, little short video, bit of engineering, bit of turning, bit of milling and problem solving. Yeah, so let's go down to the Clarkson tool grinder. So when having a break between attempting to tidy up the workshop, I happened to view one of Paul Haxby's Sheds videos on his cutter grinder. He's got a Clarkson cutter grinder like this one, Series 1 Mark 1, that he's bringing back to life, so he can use it. And yeah, I've got this one sitting here. Anyway, he had a problem on his. Yeah, you can tell this is a Mark 1 or Series 1 because it has the narrow pedal stool, you know, with Clarkson nicely cast into it and painted. The Series 2 or Mark 2, it had sort of a cabinet that it sat on, and the grinder was, you know, slightly different on the top. But yeah, they were generally very similar apart from that. And he was complaining on his that the travel on the cross slide here for moving the work into the grinding wheel had a bit of play on it. So yeah, he had, was it half a turn of play that he was moaning about. Well, look at this one. Okay, so we'll let's get it to bite so it moves. There we go, moving. See, so we go there, so there, and then we go half a turn, nothing happens. Another half a turn, nothing happens, nearly, until we get to there. There we go. We nearly got a full turn of movement there before it starts moving. See there, and then we go that way and it starts turning there. Yeah, so fairly dreadful. It's not too critical. Most of your sort of grinding movement is done with the handle here as you move the part past the grinding wheel on this this opposing cross slide here. This is where all your tool mounts go on for your grinders to sit in. This one's more just for sort of moving the work into the grinding wheel, incremental movements at a time. So anyway, I don't use it very much. Well, to be honest, it's been sitting here a couple of years. I've attempted to use it a couple of times and got so confused with you know, what wheel to use, and yeah, got boxes of wheels down here and getting all your tool angles and stuff like that. I gave up with it. Then I had a chap called Chris who I stuck a bit of work in the lathe for him, turned it up for him, but his business was sharpening cutters and grinders and tools and all sorts of things for industry. So he gave me a quick sort of run through how to set, you know, end mills and flute cutters in to sharpen them up. So yeah, I'm gradually working through my selection of cutters, but there will come a time when I'll need to sharpen them up. So I just thought, seeing Paul work on his, I thought, well, I'll give mine a go. So Paul turned up a new threaded shaft that runs through there from the handle through, but he's since found that his half nut is worn as well. And he's got a Acme style thread that he cut on his, but on my one it's just a standard, you know, sort of triangular thread here. Acme threads are better for sort of side loadings, you know, when you're pushing work in. So I don't know whether they've worn the original one out, then turned up another one just in a sort of standard triangular pitch type thread, and made a new half nut or a sort of adjustable nut underneath, which I will show you when I take this all back out again. Yeah, this was all done for visual effect. I put it back together just to show you. And we've got a reverse thread, or a left-hand thread, on the lead screw. There we go. And yeah, I suspect this has been remade because it's a metric nut on there. Drop that off like so. So there we go. So there's this adjustable sort of semi-split half nut assembly, quite nicely made. But I think somebody's made this. Yeah, it's got somebody's insignia D stamped in it. But as you can see if I can get you really close, yeah, there's hardly any thread there. It's all sort of worn away. Nearly a smooth hole. And then also this thread here, it's a fairly good fit when you start it off here, but once you get into here and all the way along, it's quite worn, and you can see the thread's really sharp, where the points are really sharp, where they've been worn side to side. So Paul turned up a new shaft for this. Yeah, I haven't seen whether he decided to make a new nut assembly for it. Which is what I'm going to do. Going to make a new nut here. This is some sort of phosphor bronze. I mean, it almost looks like copper. It's got a lot of copper in it. Quite soft. Anyway, as I don't use it very often, I've got a bit of brass, which will do the job, because it's only turning really slowly, really small amounts. So yeah, brass will do the job fine for probably my lifetime, to be honest with you. And rather than turning a new shaft up, what I'm going to do is set this up in the lathe and then go in with a threading tool and just clean this thread up and just recut it to get the profile back, and then I'll turn an internal thread on this to match this. That'll confuse them when they take it apart in years to come. And the current thread is, yeah, quite weirdly, it's a 5/8 14 pitch, so it's a pipe thread that it's got on there. Don't know why. Maybe they had a tap, left hand 5/8 pipe thread tap, who knows. So what I need to do is find out the depth of this hole from this surface here down to the centre here, so I can bore a hole or drill a hole in this piece so it's in the right place. So what I done was I reassembled this threaded shaft back in the machine, and then with a height gauge measured from this surface down to the top of the thread where it wasn't worn up this end here, and measured the diameter of it as well. So this is the depth from the way surface downwards. This is the diameter of the thread, and then I'll divide it by 2 because I want to find the centre of the hole, so that gives me that, and then I add it to my depth from the waist down to the top of the thread. That gives me this 11.21, and yeah, in imperial it's 4410 thou. And then we go to the book, and I'm doing it in thou because it's an old English machine. All the dimensions would have been in imperial when they made the unit. So yeah, 0.44, what did we say, 10, so just over 7/16. So I'm going to take a gamble that that hole depth from the waist surface down is 7/16. You know, and even if we get it a little bit out, we've got a little bit of a movement on the bolt holes here, but also I've got to machine this top hat surface on this after I've drilled the hole. So yeah, there's a bit of leeway in that as well if it's in the wrong spot. you know, I can machine it further down, or not quite so far down, where it's bearing on the bottom surface of this carriage. So I'll disassemble this. Right, let's go over to the lathe. Okay, so I just run the lathe tool, run it along just to take off the peaks of the thread where they were really sharp, just to take it down a little bit, and then just machine myself a little bit of clearance at the back here for the threading tool to go into. But the plan is just to sort of clean this thread up and get it back to profile, and get rid of this really sort of sharp profile that's there at the moment. And then once we've got that, this should be done. I'm not going to use a fixed steady because there's not a lot of room to get in here, but also I'm only taking very light cuts, and we'll take a few spring passes as well, so any distortion in the middle should hopefully be taken out. And it's only whereas Paul was cutting an Acme thread, you know, it's a lot heavier cut, whereas we're just sort of, you know, going to go in on set our cross line angle across, so we're only cutting on one side of the thread, just to sort of minimise the pressure on the tool and the rod. So I'll carry on. And I've just changed out to this offset dead centre to give us a bit more clearance for the cutting tool to come out, because it's a reverse thread. We'll be cutting from this way out this way. So we need to set our thread cutting gearbox, so we go to the threads per inch chart, and the first thing we need is V, so we need to switch this one to V. It's easier having the lathe running to get these over. And then the next one is L, which is a low gear. These are physically changed, this one and this one, but for standard threads I haven't had to change this there. I do have the spare gear in the cupboard if I ever need it, but yeah, it's normally L. And then B, so across to B there, 8, which is on the gearbox selector down here, which it is, like that. And then the final one is T, so this one to T like that. And then because we're cutting a reverse thread, we need to change the direction of the lead screw. It's currently going that way, but we'll stop the lathe for that because it does graunch a bit. Don't ask me how I know. And then we change the direction, and then when we fire it up again, see the lead screws going in the opposite direction. Handy little nugget of information. How do you know which way to have your lead screw going compared to your chuck? So when you're cutting a left hand thread, the lead screw should go in the opposite direction to your chuck, and when you cutting a standard thread, it'll turn in the same direction. There you go, nugget absorbed. Then run the lathe, engaged the half nuts, and just checked that it followed the thread pattern of the screw thread that was already on there, which it did quite nicely. So with that done, it was a case of just moving the cross slide in and across slightly, lining it all up so that the tool sits nicely in the old thread. Once that's done and all zeroed, we start the thread cutting process. Unfortunately, you can see me running the tool along it, but I don't know where the bit of film went of me actually sort of cutting the thread. I probably was far too intent on concentrating on what I was doing to clean it up, but that cleaned up really well. So I'll do a bit of talking over some of the actions because I was experimenting with a different camera and I don't think it worked out very well. So if it's blurry, I apologise, and if the sound cuts in and out, I apologise. But yeah, so basically the first thing I'd done was turn down my brass lump down to outside diameter, faced it off both sides so it was the same height as the original one. And then, as I said, after I worked out my hole position that I needed to drill, so I then moved the brass round to the mill, dropped it in the mill, used the wobbler to find all my edges, and then set that on the DRO to find the centre of the piece, and then moved it over and worked out where the outside edge was, or my sort of my top face, and then from there moved it in to my measurement that I described to you. Which was 7/16, so centre drilled that. And then ran through with a 13mm drill all the way through. I thought this would make life easy, so then I transferred the piece of work to a 4-jaw chuck and put the drill in the drill chuck and slid the piece of work over the drill, and then positioned that within the chuck, and then slowly gently closed the jaws down onto the piece of work to hopefully get me near dead centre, with hopefully a small amount of clocking with a dial gauge. Unfortunately, because this was round like this and it was grabbed into 4 jaws, it was almost impossible when the jaws clamped to stop it rolling one way or the other. So although you could get the whole central, you might find that it was going uphill or downhill in the chuck. So took it back out of the 4-jaw, dropped it in the milling machine, and just machined my 2 clearance flats that I was going to do later in the operation. Just milled them off and then popped it back in the 4-jaw chuck, and because I had 4 flat surfaces, it was a lot easier to set up and dial in ready for machining. So with the workpiece centralised, I then proceeded with a boring bar to bore out the hole from its current 13mm up to 13.5, which I sort of measured was about my depth of thread that I was sort of heading for. It's normally, the tapping drill is normally 14mm for a 7/16. So yeah, because we'd taken a bit off of the shaft, I allowed a bit, took a bit less off of the tapping size. So with that done nicely, it's a case of grinding up a internal imperial boring bar, and what I'd done was set it up on the back of the workpiece and run the lathe backwards so I could see what the tool was doing as I was cutting the thread. And because it was a left-hand thread and I was running the lathe backwards, I was cutting it sort of the reverse way you'd cut a left-hand thread. So I was going into the chuck sort of standard, if you would, with a standard thread, if you know what I mean, if that makes sense. Yeah, so so it was very close to the chuck, so this is why I got some filming of this. Yeah, this came out okay. So yeah, we'll just sort of go through that as I run through the cuts, gradually bringing it up to size, and then when we get close, withdrawing the tool out of the way. I had my 0 set on the digital readout, and also my clock gauge, keeping record of my depth of cut, so there was no problem moving the lathe tool up and out of the way, so I could sort of check it with the threaded shaft to see how far we were away, and then just sort of kept going like that. A few more cuts, and once it started to sort of thread into the hole, just checked it every few passes, and yeah, eventually we got a very nice fit. So with that threading on nicely, I took it out of the chuck, changed the chuck to a 3-jaw chuck, and set the workpiece up to machine the shoulder on the back of it, and drill and tap the threaded hole for the securing nut. And then I proceeded to face it off. It was 1/4 of an inch, so faced off 1/4 of an inch, with the leaving the boss in the centre that fitted in the hole on the bottom of the slide on the cutter grinder. And then once that was machined, it was a case of centre drilling it and drilling and tapping it for an 8mm Allen bolt so it could be secured to the cross slide as per the original. chamfered the edges, and then turned the work over, and to square the work in the chuck I used the face of the drill chuck that was still in the tailstock to gently push the work into the 3-jaw chuck once it was sort of just nipped up but not really tight, and that squares the workpiece up really nicely. And then a crafty little engineering trick, mounted a radius cutter in the tool post and set it so it was sort of one of the cutting edges was flat or 180 degrees, so that was my cutting edge, and then with the height gauge just set the cutting edge to the centre of the lathe, and then with that done you just go in and gently work it in and across and form a radius on the part. And as you can see, that works quite nicely, so it's a handy little trick, rather than having to keep grinding up radius tools for different radiuses. If you've got a small selection of radius cutters, they'll do the job just as well. And then just sort of a light face off just to get some of the tooling marks out from the 4-jaw chuck. So there you go, there's the new nut, slide nut, whatever you want to call it, made up. As you can see, it's got a little bit more body to it, so it's got more thread engagement, so that should sort of help it last a little bit longer. Yeah, Imperial threads threw us a curveball yet again. This is a 5.5mm Allen key, fits that Allen screw perfectly. And then what I normally do on my bench here, I've got a rough gauge and I just dropped it in here. So yeah, oh, it does fit in the 5/16. But anyway, I dropped it in the 8mm and it sort of dropped in there, no trouble at all. And as it was sort of metric Allen key fitted it, I assumed it was metric. So of course went and tapped this whole M8 and then discovered that the Allen screw, Allen bolt, whatever you want to call it, wouldn't fit. Just sort of a few thread engagements. So a bit of investigation with the thread gauges. It's Whitworth, bloody Whitworth Allen bolt. So who knew? Anyway, no harm done. Found an 8mm stainless Allen bolt I had kicking around, extended the thread down it, and I had to turn the head down as well so it fits in the recess on the slide on the grinder. So yeah, no harm done, and so we can keep that bolt with that one and that new bolt with that one. So this could have been the original one if it's a Whitworth thread, unless they just sort of tapped it and realised it was Whitworth and tapped it for a Whitworth hole. Yeah, I don't know. But anyway, this is all cleaned up, and yeah, always throws you because you're trying to screw it in the wrong way. But as you can see, that winds in there very nicely. Well, yeah, there might be a bit of a burr on the tapped hole that I've just put through it. We'll clean that out. Yeah, so there we go. So what I'll do is I'll assemble the grinder back up and see if we've lost some of that end float. Oh, other way, bloody left hand threads. So as the original one had a mark as well, I got out the punches and marked it with my own trademark. Yeah, unfortunately the W was a bit disappointing, and then I tried it again, made it even worse. But anyway, we know who made it. Okay, let's get assembling, put a bit of lube in there just to help it along. Wrong way. That way. There we go. Right. Bit of lubrication. Well, there. And replace the shims that obviously been put on there to take out some of the wear. Put the dimple uppermost, so when we pop the grub screw into it, it goes down into there. See, this is what threw me as well. This is this grub screw takes a metric Allen key. Odd. There we go. I'm sure somebody will know. It's probably very close to a Whitworth Allen key, if there's such a thing. Do that up a little bit. Slide that, Kate. Oh, we have an issue. Just there, just catching just there, bottom of this trough. Yeah, and I've left it a little bit tight, so easy way around, just pop it in the mill and mill off these flats down a little bit more. We should be all right. Okay, bear with. Right, try again. Forgot to turn the noise machine off. That's better. Well, the bolt holes line up, that's a good sign. Best thing to do is do it as far up as put it up this end so we can set the height of it. Because there's a bit of an up and down movement on this. Right. There we go. Right, make sure everything's nipped up. Yep, it's nipped up. Bring it this way, try and clear this handle. Right, it's as far as it goes. Let's move it down there. There we go. Just so we engage this and get the maximum travel on the handle. There we go. Right, let's turn that noise machine off before we reveal the backlash. Oh, that's better. It's like banging your head against the wall. Right, let's have a look. See, so turn it that way. Okay, there. Come back the other way. No movement, no movement. Oh. Oh, we're going to have to put a gauge on this. I can't see. Right, hang on a minute. Put it on a sturdy platform like this filing cabinet. Fairly sturdy. Let's pop that on there. Can you see that? Yeah, okay, let's pop that on. That filing cabinet's not the best platform. You can't see, can you? Hang on. There, that's better. Right, let's come back. Just to prove to you that I'm doing it. So we go to 0 there. Okay. And then we start turning it back. So we got just under 1/4 of a turn. Go to 0 that way. 0. Start turning it back. Oh, I'd say that's about 1/8. So we've reduced it from a whole turn down to 1/8. And it's a nice smooth action as well. See, let's do that again. There, 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 there. Yeah, between 1/8 and 1/4. There. Yeah, just over 3/16. Happy with that? Yeah, although I was meant to be doing something bikey, we've had a bit of, what do I call it? Side projects. Doing that, and yeah, welded up a ugly bracket to mount the camera above the lathe to hopefully improve your viewing pleasure. Yeah, I'm happy with that. Yeah, look at that. Brilliant. There we go. Side project 592 complete. So there you go. Nice little repair on the Clarkson cutter grinder. Yeah, so I think we managed to sort of salvage that shaft without having to make a new one. And yeah, there's sort of, you know, there's no need. It's going to stay on the machine. It's not going to be put in another machine. So yeah, there's no reason not to. So sometimes you can sort of save a shaft rather than have to turn up, you know, a brand new one, sort of going to all that trouble. So yeah, nice recovery. Yeah, you just have to do a little bit of jiggery pokery, sort of calculate, you know, you've taken a bit off, so yeah, make an allowance. I was lucky where I sort of bored the hole to 13.5. It worked out spot on the dot, but you could always sort of do it a little bit less, cut the thread, and then if it's too tight, you could sort of go in with a boring bar and sort of take it out a little bit more, and then continue to sort of cut your thread again, you know, so that'd work. But yeah, we were just sort of the luck of the Irish, as they say. Yeah, that turned out all right. So I hope you liked it. If you did, give us a little like, hit subscribe, and we'll see you next time. Yeah, all right. Cheerio. Right, I'm going to have some Lemsip. See you later. Hello and welcome to Tweed's Garage. We're in this video. Wonky. Yes, so didn't get Tweed's Garage. In this video, we were going to get. Oh, hello, welcome to. Let me off filming for a day. Yeah. Yeah, can't get it open.